Okay, so now, go ahead and tell me which ones we having trouble with. Go.
Can you do number 25?
Okay, let's look at 25. Rhonda has a rectangle of dimensions length by width. So basically what I would do starting this out is I would just say this is length and this is width, correct? She would like to replace it with a square that has the same area. So what's the area of this rectangle?
The length times the width.
Length LW, right?
I said
So the area is LW, right? So we want the square to have the same area. So if we draw a square and we put in here, this has an area of LW, then what would the side be? You're thinking perimeter. True?
Yeah, or 1/2. The geometric mean.
So it would just be, that is correct, but it's, I wouldn't.
LW radical.
Radical LW. Right. So for example, let's say this area is 63. So that means this over here is going to be what?
63.
So how do I find the side? Yeah, square root is 63. So I understand that? So the answer is just the square root of LW. That's not bad. All right, someone else. Go. 29. Let's look at 29. Okay, so it says a bridge connects a tunnel as shown in the figure. The bridge is 180 feet above the ground at a distance of 235 feet. So would you agree, if I'm not mistaken, then this right here would be 180?
Yes.
Okay. Because I do think it's kind of hard. All right. The bridge is 180 feet above the ground at a distance of 235 feet along the bridge out of the tunnel. The angle to the base of the summit of the cliff is a right angle. So I'm assuming this is a right angle here. That's what they're saying. You okay with that?
Yes.
So again, it's just the same shape, correct? I mean, it's what we've been doing. All right, all this. All right, so it says, what is the height of the cliff, which is X? Do you agree with that?
Yes.
So for me, what I would write down automatically is I need X, and X is part of 235. Do you agree with that?
Yes, I do.
So I would say that's the long leg and that's the short leg. Do you agree with that?
Yes.
So then what triangle has a long leg and a short leg given?
On the bottom one,
Which is what?
235 and 180.
235 over 180. That's what I think.
And that's for the height.
Yeah. So that's, so now please, 235 times 235 divided by 180. Everybody can do that on the calculator. Tell me what that is. If somebody got it already, that's great.
It told us around out, so I just got figured at 7.
Yeah, I'm okay with that. 306 point what? I like 3 decimal places actually. 306 point what? 81. Because like in math, you're going to round to 3 decimal places. So that's what I always want you to do. 306.81 what? 5. Thank you. All right. And I don't care if you put 307. I don't care if you put 306.8 or 81. All right. But just traditionally, you round to 3 decimal places. All right. So now it says, how high is the cliff from the base? So I'm assuming they're talking about this H right here, correct? Which now we can easily tell what that is now, right?
48.
400, what? 86.815. And we would call that in feet, don't forget. So I'm good with that. And now D. How am I gonna find D? Now, for me, I would just do Pythagorean theorem, honestly. So everybody agree with that? So we would square this right here, right? Plus 235 squared, and then take the square root, and that would be D. You could set it up as a proportion also, but I'm okay with that. So what is that, please?
386.618.
Anybody else get that?
I got that.
Thank you, thank you, thank you. All right, that was a nice little problem there. Somebody else now. Good for you. 28, let's look at 28. Okay, so now I'm assuming this is going to be a right angle also. I'm going to make this a little darker. So this is a right angle, right? Okay, so what I want you to do is set me up a proportion. Notice I'm not even reading. I'm assuming they're just asking me for X. Right, so set me up a proportion, try.
X over 90.
Yes, exactly right, kiddo. X over 90, and X is what? Hypotenuse, long leg, short leg, and 90 is the what? That's right. So now you have to find a short leg and a long leg.
Never mind.
What is it?
Okay, then 40.
Yeah, girl, that's it. 40 over X. You see how simple that is, right? All right, that's all there is to it. All right, and that's why I like doing short leg, long leg, hypotenuse. All right, to me, it's just easier to see. And you always identify the variable and put it with another side of the triangle, and then write down what the relationship is. And you can see it's really easy. So we would just say X is equal to 60, right? All right, and whatever that is, 60 what? Does it say feet or yards or what? Feet. All right, guys, I don't think that's that bad. Anybody have any questions? Good. Let's do 26. Okay, now this one, I'm assuming, you know, it's got to mean a connection there. All right, I just think it's off by a little bit. So let me see if that's correct. A museum has a famous statue on display. The curator places the statue in the corner, yes, of a rectangular room and builds a 15-foot long railing in front of the statue. Use the information to find how close the visitors will be able to get. So we just want to find X, right? So you just set up a proportion for me. That's what I would say, 12 over X. Now, tell me what 12 is.
12 is the long leg.
No,
Wait, 12 is the hypotenuse.
yes, sir. 12 is the hypotenuse, and then X would be
The short leg.
exactly. So now I need a hypotenuse and a short leg.
15 over.
Yes, sir. That's how easy. All right, so now somebody tell me X equals 9 times 12 divided by 15.
7.2.
Somebody said 7.2. Anybody else get that? 7.2? Yes, ma'am.
Can you please do 23?
23.
I got like really random numbers.
I'm totally okay with that.
Okay.
So which letter? I mean, you got to set up a proportion for me.
Okay.
Because I'm glad you asked me this, because again, I want to show you how you can set up a proportion. The proportion could be wrong, so you have to do something else, right? Because you can only include one variable, right?
Right.
So tell me what you're going to do first.
Y over 10.
That's exactly what I did. Y over 10. So what does Y represent?
Y is a short leg.
And then 10 is the,
Hypotenuse.
exactly. So give me a short leg and a hypotenuse.
Ten over 20.
Yes, ma'am. 10 over 20. So what does Y equal?
5.
Exactly, y equals 5. Okay, so now you just be brave, set up another proportion.
Okay, X. No, Z over 20 equals,
Good job. Z over 20. So what's Z?
Z is the hypotenuse.
No. Not if you're doing Z over 20.
Oh, Z is the long leg,
And 20 is the,
hypotenuse.
there you go. So I need a long leg and a hypotenuse.
How would I do that without using my?
I don't, I can't. Do you agree with me?
Yeah,
So now I just have to try Z over what? Instead of Z over,
10.
yeah, let's try Z over 10. I'm so glad we did this problem. Z over 10. So I didn't work on that one, correct? So now I'm trying Z over 10. So Z is what?
Or a long leg,
And a
short leg.
long leg and a short leg. Uh-oh, but I do see something right off the bat. What is X?
15.
Yeah, see, I overlooked that. That's kind of sneaky. Do you see why it's 15?
Yes,
Right, so now it solves everything. Right, so now we'll just leave it long leg over short leg. So now where's a long leg and a short leg?
15, wait, no,
Nothing, right?
yeah,
So we could go back to now Z over 15, right?
okay.
I think that'll work this time now. Do you agree with me?
I just did Pythagorean.
Yeah, and I was gonna say that too, just Pythagorean theorem, right? But I'm trying to do it just by the way they want us to do it. So let's do long leg to hypotenuse, which would have been 20 now, correct? Is that correct for you?
Yeah,
So now I need a long leg. So it'd be 15 over Z now.
yes,
There we go. So Z squared equals 300, right? So Z equals 10 radical 3. Okay, thank you. That was a good problem to do. All right, and now, because we want Z, we could have done 20 squared minus 10 squared. Do you agree with that?
yes,
Yeah. So you have options here. That's why this isn't as important, because a lot of times you can do Pythagorean theorem. All right, once you find one of the sides. All right, but that is helpful. All right. So where do you want to start? Well, the first thing I would do now, so I don't make this mistake, and this is probably what threw you off, is this is 19.
Mhm.
Right? So what proportion did you use?
I get Z over 25 equals 19 over Z.
Z over 25. So Z is the long leg to hypotenuse. Equals what?
19 over Z.
Okay, so that was easy, right? So Z squared equals 25 times 19. So Z is equal to 5 radical 19. Now what? 6 over Y. Short leg to hypotenuse. Y over 25. So Y equals 5 radical 6. So now what? X over 19. Short leg to long leg. Well, I don't mind if you do that, but here's a short leg and a long leg right here. And they're just numbers. 6 over x. So x squared equals 6 times 19, right? And 6 times 19 has nothing. So it's 60 and 54, which is 114, right? No, yeah. 60 and 54. Right?
Yeah.
Square root 114. Now you understand you can make it harder by using harder numbers, right? So I always try to find the ones that don't have the square roots in it, so I don't have to multiply them, but it's not a big deal. All right, now today's a super easy day. So let me have these real quick.
All the messages.
And then I don't care about the messiness. Okay, so now again, very simple, very simple. This whole chapter is actually very simple. So again, today it's just, these are all right triangles. Now, the main thing is I am going to show you quick ways of doing it. All right, now, what I want to do is start off by number one is I want everybody to write down 3 squared plus 3 squared equals x squared. That's not a mystery. I know everybody knows that, right? So now I would do 9 plus 9 equals x squared. Now, instead of adding those two nines, well, because there are two nines here, I'm going to write 2 times 9. Now, the reason why I do that is because now when I take the square root, I just know it's what? 3 radical 2. All right, of course you can put 18 and then break down 18. All right, 9 times 2. All right, but this is how I would like your brain to think. All right, when you see 9 plus 9, I want you to say there are 2 9s. All right, that's beneficial. Now, the next thing I told you was this. 3 is 3 times 1. This 3 is 3 times 1. So that means this is 3 times the Pythagorean theorem of these numbers that are left. All right. So what's 1 squared plus 1 squared? 2, right? So that's how I got in my head just 3 radical 2. All right. Now you might be a little bit sketchy on that. So I'm going to show you on number 2, the same principle. What common factor is in 9 and 15?
3.
So this is 3 times 3. This is 3 times 5. So this has to be 3 times the square root, right? And what's 5 squared?
25.
25. What's 3 squared? 25 minus 9? 16. You're right. It is 16. And then the square root of 16 is what? 4. So then 3 times 4 is what? 12. Okay. Now, that brings me to this. In your standardized tests, there's called Pythagorean triples. I really need you to know these. It'll help you out tremendously. All right. And if you know the triples, you don't have to do the Pythagorean theorem. You can just tell me the answer. All right. The first one that's super major that you see all the time is 3, 4, 5. Again, this is going to save you a bunch of time if you can remember these triples. Then 5, 12, 13, 8, 15, 17, and then 7, 24, 25. Those triples occur a lot. And there's more, but those are the ones that are most common. So now, how did I know this was actually 12 without doing any work? It's a triple. It's a triple multiplied by what? 3. So 9, 12, 15. So 9, 12, 15. Is everybody with me on that? So let's look at number 3. Let's see if we can do it without doing 65 squared minus 25 squared square root. What is 65? 5 times what?
13.
13. What's 25? 5 times 5. So this has to be 5 times 12. It's really simple, guys. 5 times 12. And what's 5 times 12? 60. Everybody good with this? So you're looking up here going 5, 12, 13. 13, 5. So the other one had to be 12. Everybody good with that? Now, some kids go, I hate doing that. Can I just do Pythagorean? Yes, but the numbers are big, right? And sometimes on standardized tests, you're not allowed to use a calculator. So they're testing whether or not you would know the triples. All right. Anybody have any issues? All right, so let's look at number 4. Can anybody tell me what number 4 has to be? 3/9, which is what? 1/3. That's very good. Now, again, remember what I'm trying to show you guys. I have one more semester with you. Right? If you don't know something, just tell me. Right? If you can't see that's 1/3, just tell me. Or if you don't know that it's 3/9, just tell me. Anybody have any problems with that?
Can you explain that?
Yeah. So do you understand? I have a 3, 4, 5 right triangle, right? I just divided them by 9. Now you see, right? That's what I'm saying. Okay, show me. I don't care. And 3/9 reduces to 1/3. That's all there is to it. It's a multiple. All right. So let's look over here. 16 and 33. Do I see anything? No. Right. So this one's kind of annoying. All right. So now what we're going to do is we have to go 16 squared. All right. So 16 squared is 256 plus, somebody tell me what 33 squared is.
1089.
Equals x squared. So now when we add those together, I get what? Did you say 1,345, right? All right, now we're going to take the square root of that. And now I'm going to ask you, I don't want the decimal. All right, we really don't write in decimals anymore, but I'm not sure if I can break this down, correct? Does everybody agree? I know there's a 5 in here, right? So I want everybody to take 1345 and divide it by 5. What's that? How much? 269. And I think 269 is prime. So our answer is just what? Square root of 1345. All right, let's go over here now. Again, this one's kind of annoying. It's not a triple. So we would say x squared is equal to 28 squared minus 11 squared. Does everybody see what I'm doing on that? Well, they gave me the hypotenuse, right? So I just did the hypotenuse minus the leg.
Oh, and then I'll equal
Yeah,
one.
that's right. You see what I'm saying, right?
Yeah.
So now somebody tell me what 28 squared is. Minus 11 squared, which is how much? Well, yeah, but what's 28 squared minus 121 squared? 600 what? 663. So x is equal to the square root. So I know 3 goes into that, right? 3 times 2, 2, 1. I think 221 is prime. So it's just the square root of 663. All right, I'm good with that. Number 7. Is that a triple?
Yeah, it's 15.
Everybody see how nice that is, right? All right, if you know the triples, you just write down the answer, 15. All right, over here, what do I notice? 24 and 45. 3 times what? And then 24 is 3 times 8. So is 8, 15, 17, right? So 3 times 17. X equals 51. Everybody okay with that? Anybody? All right, very nice. Number 9. Uh-oh. What goes in here? 4 times 7. 4 times what? So 7, 24, 25. So that's 4 times 25, which is what? Good. All right, is everybody agreeing with me? That's kind of easy. All right, that's kind of easy. All right. Especially when you know the triples, makes life really easy. All right. Now we have to classify this as acute, right, or obtuse, but it says first determine whether the set is or can be a triangle. All right, we already learned to determine whether it can be a triangle. If it's the sum of the two smaller sides has to be greater than the large side. All right. So is 10 a triangle? So is it a right triangle? We don't have to do this one, right? Because that's a what? Triple, right? It's a 3, 4, 5 right triangle. Hello? Everybody good? This I'm just going to write down as a right triangle. If it's what? Yeah, it's a right triangle. Now, how do I know it's a right triangle? Because I can do 30 squared plus 40 squared, that equals 50 squared. Okay, so now is 20, 30, 40 a triangle? Yes, because 20 plus 30 is greater than what? 40. Now, let me see if this makes sense to you. All right, I'm going to draw a right triangle. I'm going to try to. All right, and just for visual effect, please look. Right now, a squared plus b squared equals c squared, correct? Is everybody okay with that? Yeah. Now, what would happen if I would, or if I take c and I make it bigger? What is that gonna do to this angle right here? It becomes obtuse, right? So in my mind, if c squared is greater than a squared plus b squared, it's what? It's obtuse. But if c squared is what? Less than a squared plus b squared, it's what? It's acute. And to me, that just made perfectly good sense. All right, if I shorten c, that creates an acute angle. If I lengthen c, it creates an obtuse angle. All right, so these are the rules. If c squared equals a squared plus b squared, it's a right triangle. Everybody good with that? So now let's look at 11. We're always comparing c squared. So 40 squared is equal, well, I always leave a blank there. 40 squared compared to 30 squared plus 20 squared. 1600, 900 plus 400. So I know 1600 is greater than that. So that means that's a what? If c squared is bigger, it's obtuse, right?
Oh.
Yep, obtuse. And again, remember, if c is bigger, if you enlarge b, that creates, or if you enlarge c, that creates an obtuse angle. If you shorten c, it makes an acute. Does that make sense? All right, so is this a triangle, number 12? Yeah, that's a triangle. All right, so now I'm comparing 30 squared.
Is it just a right triangle because of the triples?
Yeah. Well, 9. Oh, 6. Yeah, that's brilliant. So this could be 6 times 3, 4, 5. There you go. Thank you. I don't feel like doing the work. All right, that was automatically a right triangle because he recognized the triples. Okay, 13. 6, 8. Is that greater than 9? So it is a triangle. So now we're comparing 81 to 36 plus 64. And what is 81 compared to 36 plus 64? Less than, so it's what? Acute. Now over here again, is this even a triangle? No triangle. See, a lot of kids don't take the time to check, and so what happens is they think it's an acute or obtuse, all right, without understanding that it's not a triangle because these two aren't greater than the third. Okay, so over here, does everybody agree this is a triangle? There's a common what here? 5. So I'm looking at this as 5 times 2, 5 times 3, and 5 times 4. So I'm only using 2, 3, and 4. Does everybody agree? So I'm comparing 16 to 4 plus 9. And 16 is what? Greater than, so we have here a obtuse. All right, yeah, let's go ahead and do this now. Now, first of all, we need to calculate whether or not this is a triangle. Now, yeah, this is really close, I think. So somebody do the square root of 5 plus 2 square root of 13 and tell me what that decimal is.
9.447.
Right, and the square root of 13 is definitely less than that, right?
Yeah,
Mhm.
Wait a minute, how can that be 9.4? I don't think it's 9.4. Square root of 5 is like 2.2. 1.7, that's like 3.4. I got to be somewhere around 5.6. Is it around 5.6? Yeah, yeah. And what's the square root of 13?
2.6.
So it's still a triangle. Agreed? All right. So now we know that the square root of 13 is the biggest, correct? So that would just be 13 compared to, okay, now this, be careful, 13 compared to 5 plus
12.
12. Thank you. So that's what? So it's acute. Lots of practice today with radicals.
How do you know radical 5 is 2 times 2?
No, radical 5 is 2.2. Radical 3 is about 3.4. Because I know square root of 3 is 1.71 actually. So I just did real quick 1.7 times 2 and got 3.4. And I knew square root of 5 is a little bit more than square root of 4. Square root of 4 is 2, so it's just a little bit more than 2. Because the square root of 5 squared is 5, and that squared is 12. 2 radical 3 squared, what is that? How did you get that? What's 2 squared? What's radical 3 squared? Okay, let's check out this one. These numbers are kind of close too. Now, basically, these all have a 2 in them, correct? So I'm just comparing 1, square root of 2, and square root of 3. So that's definitely a triangle. All right, that's definitely a triangle. So now we're comparing square root of 3 plus, is equal to, what am I doing here? Compared to 2 squared plus 2 radical 2 squared. So 3 compared to 4 plus 8. Oh, hold on. I'm sorry, guys. I made a mistake. This right. I used the 2's here and I shouldn't have. So all the numbers I'm using are 1, square root of 2, and square root of 3. See, I try to. So square root of 3 squared compared to 1 squared plus square root of 2 squared.
So the right triangle?
Yes, 1 plus 2. So it's equal to. So that's a right triangle. Yeah. All right, I was trying to get too fancy and I forgot. I crossed out the 2's. All right, I'm happy with that. Ooh, I think 9, 40, and 41 is another triple. Does everybody verify that for me? 41 squared is equal to 9 squared plus 40 squared. Is that correct? Is that 1681? Help me, guys. You got the calculators. So this is a right triangle. Right. So I just remembered this is a common, not as common because 9, 40, and 41. All right, but that is a triple. Everybody good with that? All right, I think that's all I need to discuss. Ooh, let's come down here and do a couple of word problems just to make sure. Now, everybody should understand the word problems. All right. They're just right triangles. So all you have to do is figure out how to draw the right triangle. All right, so let's look at 37 just to make sure. All right, so it says construction workers are building a marble sidewalk around a park that is shaped like a right triangle. All right, so we're making a right triangle. And it says each marble slab adds 2 feet to the length of the sidewalk. The workers find that exactly 1071 and 1840 slabs are required to make the sidewalk along the 2 shorter legs. So this is 1071 and this is 1840. Yeah, I don't understand why that was kind of silly. Does it say how many slabs are required to make the sidewalk that runs along the long side of the park? There's nothing to it, right? So I'm sure there's a relationship here, but you guys have your calculator, so just do that for me.
No. 4 million.
No. You forgot to do the square root.
2,129.
Is it exactly
slabs. Yeah, I got that.
2,000 what?
129 slabs.
Yeah. Okay, let's look at 38. Is 20, 21, 28 a right triangle?
No.
No, because 20 squared plus 21 squared does not equal 28 squared. All right, I'm good with that. The bell's going to ring here in a couple minutes. All right, so try to finish that up the best you can.
Hey, Mr. Sherman, do you care if I throw away all my papers?
No, first semester is over.
Alright, because I need to start organizing.
Yeah, start organized. All right.
Oh, geez.
All right, good job today, guys. Finish that up now. Yeah.